Inside Visual Studio, you have several project templates. There's one to create an application, there's a few for unit testing, and then there's two types of libraries. The class library allows you to use more C# features in its public interface, but doesn't let you share it as widely. On the other hand, a component is a little bit more restrictive in the language features you're allowed to use in the public parts of the component, but it is more flexible in that you can share it across all UWP languages. Apps all tend to have the following structure. There's an application class. Each application has a window. Inside the window, you tend to load a frame, and then a frame displays a single page to the user. And then off to the side, there's a manifest which has the metadata for your app. Let's go through each one of these parts, starting with page. A page encapsulates both the UI and the behavior for some particular part of your application. So in the UI, you might have layout panel or panels, and then multiple controls that show your data to the user. Generally, a page occupies an entire screen, although that is definitely form factor dependent. You'll generally have one page for each part of your app. If you were doing some sort of fictitious contacts app here, you might have a contacts page to show all contacts, details for the details view of a single contact, edit, and probably more beyond just those three. Each one of these classes must inherit from the library page class. The implementation for each page has two files. Your UI tends to be done in Extensible Application Markup Language, or XAML. Notice over here on the left-hand side, we have a list view to display our contacts. And then you'll have a code behind file. In this case, we'd probably have like a selection changed handler for the list view. Next, we have the frame class. Frame is optional. You don't have to use it, but most UWP apps do. And the starter template creates a frame for you. Frame does two things. It shows a single page to the user, and it also records the history of the pages that the user navigated through. Notice we have a navigate method here, and it takes as a parameter the type object for the page that you'd like to show the user. And then we have go back and go forward methods. And the intuition here is fairly simple. It works like a web browser. So if you call go back or go forward, it's like using the forward and back buttons inside your web browser. On the other hand, if you click on a link inside a page, that's analogous to calling the navigate method here. So that sends you off down a different path and clears the forward part of the history. Here's a bit of sample code. I have a handler here for a back button, and notice I just say if frame.can go back, then navigate back to the previous page. Notice here I'm inside a page. From the page class, I inherit a property named frame. We have a frame and we ask the frame to navigate to a particular page, like in this case, the details page. The frame creates the details page object for us and then sets itself as the value for this frame property. In other words, a page always knows which frame is hosting it, so it has easy access through that inherited frame property. And then down here, I'm calling navigate. This is the type of the destination page. And then I have an optional parameter. There's two versions of navigate, one that takes a parameter and one that doesn't. And here, for example, if I'm on the details page and I'm going to the edit page, I might want to pass across the ID of the current contact so that the edit page can load the appropriate data. Next, we have a window class. Every app has a window. The window gets created automatically at app startup. Window has this property called content, which is a UI element. Whatever you assign to content, that's what the user sees for your app. Typically, you're going to load a frame into here, and we'll see how that works in just a moment. But technically, any UI element is eligible. This is your user interface. Then there's an activate method. You call this method at startup to tell Windows that your UI is created and ready to go. You're ready to have your app visible to the user. And finally, this is a really important one, the current property. Notice this is static. This is the way you in your app access your window. Next is the application class. So there is a base class called application in the standard library. When you create a new app using the blank app template, there is a app class which inherits from application that gets generated for you automatically. Application does several things for you. It serves as your entry point, so it's analogous to main. It has a bunch of lifecycle methods, so you get notified through events on the application class when, for example, your app gets transitioned into the background or your app gets suspended. We'll see how that works in the next section. You can also load app-wide resources, things like fonts and colors and other things. Anything that you want to share across all the pages of your app, you can use the app class for that. And finally, there's a hook here to deal with unhandled exceptions. At startup, Windows creates an instance of your app class for you. And if you're launched from a normal tile, then what happens inside your app class, the Onlaunch method here gets called. And intuitively, you can think of this as your main. This is your entry point for most common activation scenarios. Inside here, it's your job to create your UI, show that UI to the user, and then tell Windows that you're ready. So here I create the UI, and I've chosen to use a frame. That's not required, but it's very common. And I'm saying here to start at the all contacts view. So I pass in contacts page right here. And then I load that frame as my UI. Remember, whatever you assign to content of the window, that's what the user sees. And finally, we call activate, which tells Windows that your app's UI is ready, and therefore your app is ready to be shown to the user. The last file we need to look at is your app's manifest. It is an XML file that contains all your app's metadata. For example, it has your app's identity, which is the name of your app, your name as the publisher, and so on. All your images, your app's capabilities. For example, if your app needs to access the webcam, you would check out the webcam box in your capabilities of your manifest, and then that information would be available to the user in the Windows Store. The user could look at what your app needs to access on their machine and use that in order to decide whether or not to install your application. And finally, your declarations indicate how your app interacts with other apps. For example, is your app a share target? And if so, what kind of data can your app accept? For example, if the user shares an image, should your app be one of those that are listed as available to accept that image as a target? You configure your manifest in Visual Studio. It has a nice GUI to let you do that. Notice the tabs here across the top mostly match up to what we were just talking about. So your identity information is in the application tab and a little bit in the packaging tab. Your images are here in visual assets and so on. Once you've built your app and it's time to run, use the standard toolbar here, and there's a drop down, see where it says local machine. You drop that down and you choose whether you want to run on the local device, remote machine, an attached device, an emulator, and so on. Do be sure to save your project to the local disk. Running from a network share isn't supported. The build process is different between debug and release build. The debug build is similar to what you're familiar with from traditional .NET application development. So you start with your C# source, the compilation translates from C# to IL, the IL gets deployed to the device or the emulator, and then at runtime, the IL is JIT compiled into binary and executed on the device. Release builds are different though. Release builds use the .NET native toolchain to compile straight from C# all the way to binary. It's then binary that gets deployed to the device, and at runtime then there's no JIT compile. Please test your apps periodically in release build because that's the environment that the user will experience when they install your app from the store. Once your testing is complete and it's time to upload to the store, you're going to do what's called a store package creation. And you can see in Visual Studio, you use this menu, project, store, create app package. You'll create a single file with a .appxupload extension. That package contains IL. You upload it to the store. Inside the store, that IL is compiled to native code, and it uses the same .NET native toolchain that you use when you do your local release builds. Then when the user comes along and installs your app on their device, they download and install only the binary that's appropriate for their device, and at runtime, they are executing native code.